have a question. What does this limit equal to? A1, B3, C infinity, or D does not exist? You might be tempted to answer B, because if you use L'Hopital, you get the derivative of 3x, which is 3, and the derivative of x minus 7, which is 1. You get 3 over 1, but you can't use L'Hopital, because you can only use L'Hopital when you get another combination of the kind 0 over 0 or infinity over infinity. That's why you can't use it. And here you don't get that kind of another combination. What you get is when you plug in 7, 3 times 7 over 7 minus 7 is equal to 21 divided by 0, which is not. Why do? It's not infinity either, because even though the limit as x approaches 0 of 1 over x is equal to plus infinity, the limit as x divided by x minus 7 and it approaches 0, this is not the same, obviously. So this is not equal to infinity. So where is it then? Well, let's do linear substitution. Let x minus 7 equal u. Now let's solve for x, which if we sum 7 on both sides, x is equal to u plus 7. Now substitute x and x minus 7 with u plus 7 on your original expression. You'll get 3 times x is equal to 7. So u equals 7 divided by x minus 7, but x minus 7 is equal to u. And since x approaches 7, we will plug it in here into this one, you'll get u approaches 0. So that's why the limit is the limit as u approaches 0. So this limit and this limit are the same. Now let's simplify this. So let's multiply 3 by each of these terms. So 3 times u is equal to 2, plus 7 times u is equal to 1, and this is divided by 2. Now we can separate the denominator each into 2 fractions, and now we can cancel out u with u, and we are left with 3 plus 21 over u. And this was the limit as u approaches 0 of 3 plus 21 over u. Now we can separate this limit, and plus the limit as u approaches 0 of 1 over u. Now the derivative, we can say Eureka, because we know that the limit as x approaches 0 of 1 over x is equal to infinity, and you could say, oh, therefore it is equal to infinity, and 3 plus infinity. And this is not like that, because this is a very common misconception that calculus students have, because when calculus teachers write this limit, they commonly imply that this is the same as the limit as x approaches 0 plus, 0 from the right, of 1 over x. These two are not the same, but for simplicity's sake, they flip like that. So, in fact, this limit over here doesn't exist, because visualize the graph of the function 1 over x. It looks something like, and look at as we approach 0 from the right, the limit goes to plus infinity, and as we approach 0 from the left, the limit approaches minus. And since they're not equal, the limit doesn't exist. So since this limit doesn't exist, neither does this limit exist. And therefore, this limit doesn't exist, and neither does this limit. So the choice is option D. It doesn't exist.